Welcome back again. In 13.2, we are talking about integral of vector function projection motion or projectile motion. So here, as we mentioned in the 13.1, look like the first calculus one, like how to find, for example, if your RT is RT equal to, for example, T squared J, that we say square root of TK. When we say derivative, we are doing like that. We say first is equal to first derivative I 2TJ 1 over 2 square root of TK. You know what I mean. So it means that one by one. The same thing is true for integral of T. When I say RT dt, means that come take, okay, first part by I, okay, second part by J, and by T طبعا, that we say J, the result by J, the result by K, then square root of T dt multiply K when you finish. What's equal to, in this example, I'll get what? T square over 2 I, T to power 3 over 3 J, A, T to power 1 over 2, it will be what? 3 over 2 K. You got it? So it means that one by one, component by component. So that's what we have here. You can see from example number 1, we are going to solve, cosine T, we say is equal to sine T. How about 1, we say is equal to T. How about minus 2t? We say is equal to minus 2t square over square minus t square. Then, when you finalize all ijk plus c, instead of one by one c1, c2, c3, just add when you finish, say plus c. You got it here? Good. So this is the example, and it's very important, and you know how to do it. How about if we have what? Definite integral. What do you mean by definite integral? In calculus 1, we see that one is called integral, but if I say from 0 to 1, RT dt, because I have boundary, upper boundary and lower boundary, okay, upper limit and lower limit, so we say is definite integral. So how we find them? When you finish, right? When you answer, for example, if I have the same example, the previous one, when I finish all this one, I say what? I say equal to t squared 2 plus t cubed 3 j I t 3 over 2 k from 0 to 1. And you know how to do it, right? Upper minus lower, you know. So I will get what in this example? 1 over 2 I 1 over 3 j 2 over 3 k. You know what? Why 2 over 3? Is that clear? How about the other? Minus 0, 0, 0. So I'm not going to write. How about this example? Of course, I'm going to find cosine is equal to sine. 1 equal to t. 2t is equal to t squared. Then from 0 to pi. So I'm going to put a pi. I'll get what? Sine of pi? 0. How about here? I'll get pi minus 0. How about here? I'll get pi squared minus 0 squared. Then it will be 0 pi t minus pi squared k. What's that? Is the integral of RT when t between 0 to pi. Did you understand? Is there any things which is unclear? Dears? No question? Kaka? Good. Example 3 is important, and listen, and we have something. Look. You say what? And of course, we have something that, like that at the end of this chapter, in the advanced calculus, we have something called conservative field. We are going to use the same technique that we used here. Now we have a technique So I recommend you to read the question twice. I'm going to pause the record for read. What's given? The acceleration is given. So, and what else? Initial point. What does mean initial point? Starting, right? Starting, good. What else? What else? What was the question? Find what? What means that? If I translate this one to mathematics, this is a physics one, right? So we will translate it. So we have second derivative, am I right? Also we have first derivative, am I right? Acceleration, velocity, okay, what else? Initial point, RT at 0. So we have 0 here, understood? What else? We have a 3. What else? Velocity. What was the question? RT equal to what? The general form of RT. And the previous section, 13.1, I gave you R, you find the first derivative, second derivative, like that. How about here? Because we are talking about integral. I will give you the second derivative, find the first derivative, and find the function. So it means that what? Use what? Integral, right? From function, first derivative, second derivative, you'll get what? How about vice versa? Right? Means that twice, or take two times integral. Did you get the idea? You get the idea before solving? Good. So what we have? We have, for example, AT equal to minus 3 cosine t minus 3 sine t plus 2k. Tamam? Good. Silent, please. Silent. Good. Now, first integral. If I took the first integral, I'll get what? Am I right? How about left? How about right side of the equation? Cosine is equal to sine. How about sine? Minus cosine. How about 2? Clear? What's that? It's the first derivative. Okay. Of course we have what? We say that after each integral, I'm going to put a constant. You know why. Good. Then, what's the idea here? You can write, we need to find the value of C1 equal to what? Y to get RT. To get RT, you need to find the value C1. Maybe C1 is 2I, 2J, 2K, who knows? Because we have an unknown here, like a constant, we need to find VT correctly with I, J, K, without any exceptional or more things. Maybe you have 2I, 2J, 2K, I don't know. So how we find value of I, C1, sorry, yes?
By the V and 0.
V and 0, you're right. Because what was the given? We say that. That's the given for what? To use them, right? T0, V what? V at 0 is equal to what? 3J. So give me V0 is equal to what here? Equal to what? Minus 3 sine 0 I, am I right? Plus 3 cosine 0 J plus 2 0k plus, is that right? Was equal to what from right? And that one is given. Am I right? جمع عدم given. How? How do you know? Is equal to what? 3j. Clear? Good. أبي معنى استفادة لكن. So you need to use the given. So why we have the given if you are not using it, right? So I'm going to use this. Okay. Then compare. Now Vt plus C at 0 equal to this. And how about the given is this? So compare sine of 0, 0i, 3j, 0k, C1. So tell me C1 is equal to what? 0. Because that one remove, that one is equal to nothing. So okay, C1 equal to 0. So Vt, the general, Vt is equal to what? Minus 3 sine t, am I right? I, a 3 cosine tj, a 2 tk. How about C1? Now it's clear. So how I get R? Again, take an integral. You are right. Wania? Is that clear? So I'll get what? From left? RT. Good. Well done. Right? How about here? Equal to? Equal to? I say don't be busy. I don't see why you use it. Equal to? Yeah. 3 cosine ti a 3 sine tj Thank you. Did I ask you about C2? No. So I want an RT without C, right? Maybe C2 is something with I, something with J, something with K. So we need to go to get more information in here. So where's the information? Where's the given information? What's that mean? Am I right? Start point IC, right? You're right. And here's the given. So I'll get what? Look at the answer again circa. So C equal to 0, we find C1. And here's again C2 or C cat 0, C1 equal to 0. Then here's the C2, we have 3i. Why? Because here at in your lecture note you can write 0. It's 3 zeros equal to 3i, means that RT equal to 3i 0j 0k. At 20 you can add this one in your note. Good. Then I'll get what? RT equal جارية at 0 طبعا. Right? I'll get what? Look. RT at 0 is equal to 3 cosine 0, 3 sine 0, 0k C2. And here is equal to what? By given, make the green, 3i C2. Again, in your exercise, I think C1 or one of them is not equal to 0. Okay? When you solve them, usually it's not every time is equal to 0. So please solve the exercises. Then you'll get the RT shape, which is equal to what? 3. What? Sine T. Am I right? Well, I forget. Let me see. Cosine. Okay. 3 cosine T. 3 sine T A plus what? A T square K plus C2. C2 0. This is your answer. It was easy, but need a little bit technique and how to substitute. Understood? Do you have any question, dears? Yes? That one? Here? Amen? In the second, when we have VT and we need to find RT, we got something C2. To find C2, we use that one. The دوزینه C2 we use them. أولا C1 ها چی من بکار هنا؟ V. How about in C2? أولا کیو هاتوا؟ Given when T is equal to 0. You got it? First position, the location. Before, he was on the mountain before gliding, before throwing himself down to be dying. Okay? You got it? Yes? Good. Last thing in this section, we have what? We have a vector and of ideal projectile motion. We have an ideal, we have many things, projectile motion or something, but I just use this rule. We have ideal projectile motion. Look at the equation. This one look like cosine. We have a V naught just, and the angle, of course, clear. And how about this one? We have V naught angle T on J. So we have I plus something J. What's here? We have like X. What's here? Like Y. X is equal to what? V naught cosine alpha. How about Y equal to what? V naught sine alpha minus 1 over 2 gravity. And you know what's a gravity. Of course, you passed the, I think, general physics 2, right? As well. Good. So you have a gravity and T square. This is rule. Please try to use it to make memorize it, not just by memorizing, by using, practicing. So you need to solve 2 examples. To get more example, read this one. A projectile fired from the origin over a horizontal ground at the initial point speed, that one. Initial point speed, so you have a speed here. Okay, what else? The angle 60. Okay, where will be the projectile after 10 seconds? T2. So how we solve it? You can see from the solution, V naught alpha, gravity, T, right? Because you have T as well here. We have T here, we have gravity, we have again T, we have alpha, we have V naught. So everything is given. Just put on the rule. You have a rule. So here we are, 500, 1 over 2, because cosine of 60 is equal to 1 over 2, and T is 10, then you'll get something like that. Clear, dears? Just rule and use it, and put it or substitute it. Nothing else. You have exercise, enjoy with it. I know you like to solve. So, okay, solve. Any question about 13.2? Dears?